Hey, this is Mr. Tatro, Mr. T. Today we're going to discuss making ductwork. Ductwork can be made in several different ways. There's going to be one piece, two piece, or three piece. What that means is, one piece ductwork, what that means is the ductwork is all made out of one piece of metal. Made out of one piece of metal, got our Pittsburgh lock return flange. The two would go together, and we'd hammer that over for our seam. There's also two-piece ductwork. So just as the name implies, it's two pieces made to our sizes that would both, one side would have a Pittsburgh, one side would have a flange. And again, we would put our pieces together, hammer over our Pittsburgh lock, and that would be our ductwork. The third way is another version of two-piece ductwork. It would basically be a U for one side and a cap for the other. Depending on our size of ductwork and size of our equipment, depends on how we would make our ductwork. So what we're going to do today is a one-piece ductwork. So we're going to do a one-piece ductwork. It's all 4 inches, 4 by 4 square. So our cut size is 17 1/4 by 9. We have our 4-inch dimensions. 4 times 4 would be 16. Our Pittsburgh lock allowance is 1 inch. And our return flange is 1/4. So when we add those all up together, we get our 17 1/4 inch piece. Our piece is sheared to size. Now we would start our layout. Okay? Anytime we start a layout, we're going to start in the bottom left corner and work our way left to right. Even though our picture is going vertical, we're going to turn this. And we're going to call this our bottom left, and we're going to work left to right. So our first dimension is 1 inch from the left for our Pittsburgh lock, and also 1 inch for our bottom. We're doing 1 inch big end, small end, depending on what you're using for slip and drive cleats or TDC would dictate what the ends of our duct would be. So I'm going to use a scratch gauge. I'm going to mark my 1 inch on the bottom. I'm also going to mark a 1/2 inch at the same time on the left. I'm going to do my 1 inch for my Pittsburgh. And I'm also going to mimic that on the top. So I have my 1 inch from the left for our Pittsburgh. I have my 1/2 inch and 1 inch top and bottom for our slip and drive cleats. So again, the dimensions are going to be, we're making a 4-inch square. So it's going to be 4-inch spacing in between. So using a steel rule, starting from my Pittsburgh lock line, I'm going to mark at 4-inch increments. Now if I did it right, I should end up with a 1/4 inch for my return flange. Plus or minus a 1/16 would be fine. Mine ended up at that 1/4 inch mark, so I using a scratch gauge, I marked my 1/4 inch. So now using a combination square, I would mark my intersections for my bend lines at my 4-inch intervals. Depending on the size of my ductwork, I might have to use a framing square or a T-square. I might have to mark 2 points and connect with a circumference rule or a 4-foot rule, whatever the case might be. So important part when we're using a square, we don't want to put our square right on our dimension. We want it slightly off our dimension, so when we draw our line, the line goes through the dimension if we're using a Sharpie. If we're using a scratch awl, would make a much finer line. I could put the square right on that line. But for demonstration purposes, it's much easier using a Sharpie. You can see what's going on. The last thing I have to do is I have to add all my angles. Again, depending on what we're doing, if we're doing TDC or slip and drive cleats would dictate what that angle is going to be. I'm just going to do 30-degree angles for demonstration. Use my steel protractor. I'm just going to get every one of my intersections, and I'm going to mark my 30-degree angles. I do one way, flip my protractor to the other side, and mark all my angles. If I were using notching snips, double cut snips, I wouldn't have to do that. I could just center them on that and do my notching. I'm going to do everything with aviation snips, so that's why I'm drawing all my angles. When we do any cutting, obviously we're going to wear our safety glasses and work gloves. Our metal is very sharp, very easy to cut ourselves, so we want to make sure we are using gloves and our safety glasses, obviously, for eye safety. So because all the cuts are straight, I'm just going to use straight aviation snips. I'm going to notch out my corners first, and then I'll go back and do all my angle cuts. Make sure we don't overcut our ends. Put the end of the snip to the end of your cut, so we don't overcut our ends. On the return flange for our Pittsburgh, I'm just cutting a very, very slight angle. I'm doing about a 10-degree angle. I just don't want it to be exactly square. I'm going to do the same to the other side. And again, depending on what our connection system is, whether it's slip and drive, dictates what I'm going to do with the rest of my bends. So now my part is all notched out and ready to go. So the first thing I'm going to do is for my Pittsburgh lock. Use the lock forming machine. Making sure I have my part up against the guide bar. Slide it in. Let the machine do the work. So I have my Pittsburgh lock bent. Last, all I have to do I just have to make all my 90-degree bends up. We're going to start from the return flange and work our way towards the Pittsburgh lock. That way I can get all my bends in. You have to start with that return flange, or you might not be able to bend your part. So, using a standard hand brick, I'm going to put my part all the way in the sheet, starting from my 1/4-inch bend. And I'm going to bend 4 90-degree bends. You want to make sure the apron or bending break basically is parallel to the floor. That'll give us our 90-degree bend. So having formed my piece, again, it's one piece of metal that's going to become my ductwork. So all I have to do now, insert my return flange into the Pittsburgh, make sure my ends of the ductwork line up, simply hammer, or air hammer, depending on the size of our ductwork, hammer my ductwork over. And again, depending on if we're using TVC, slip and drive cleats, I would bend for slip and drive or whatever the case might be for our connections. Okay. And again, the ductwork, for demonstration purposes, this duct is actually only 8 inches long. The duct would be made to fit whatever application we're doing, whether it was residential or commercial, large industrial, whatever the case may be. And there we have our completed one-piece ductwork.